Good day, great minds, and welcome to today's class. Today we'll be discussing a very important aspect of mathematics, which is called indices. So anytime we talk about indices, they're just numbers with powers called the index. For instance, if you have 3 to the power 2, this one is called the base, this one is called the power, which can also be called the index. So this is what we call indices. So let's move straight to the laws of indices. Laws of indices. Now, this law states that for all A, B, C not equal to 0, are A to the power B multiplied by A to the power C is equal to A to the power B plus C. And this is called product of numbers with the same product of numbers with the same base. And the second one states that A to the power B divided by A to the power C is the same thing as A to the power B minus C. And this can also be called division of numbers with same base. Now we have another one that says that A to the power B C is the same thing as A to the power B C. And this can be called numbers with double power. Numbers with double powers. Double power. Then another one is I have another one that says that A to the power minus 1 is the same thing as 1 over A to the power 1, which is the same thing as 1 over A. And this is called negative power, numbers with negative power. I'm gonna do this so that this will enter. This one is called numbers with double power. And then this one is numbers with negative power. Numbers with negative powers. And then another one still says that A to the power B over C. A raised to the power B over C is the same thing as C root of A to the power B. And this is, can call this one numbers with fractional power. Numbers with fractional power. And then we still have another one, VI This one says that a to the power minus b over c is the same thing as 1 over c root of a, c root of a all to the power b. And this can also be called numbers with negative fractional power. Fractional power. Then we still have others. This one. We still have the one that says that this number VII. This one says that a to the power 0, of course, is equal to 1. This one. And then we have VIII. The other one that says AB raised to the power C is the same thing as A raised to the power C times B raised to the power C. And then the very last one, I guess, IX. This one says that A to the power C B. A to the power C B is the same thing as A to the power C times B to the power 1. So these are the laws of indices. Product of numbers with the same base. That is, any number, when two numbers are the same, when the base of two numbers are the same, you just add their powers to get their answer. Then the same thing, when the bases are the same for division, you just subtract the powers. Then the one that has double power is just the same thing as multiplying the powers. The one with negative 1 is just the inverse of that number. And this one also. For this one, number to the power of fraction, just take the root of the denominator of that fraction. Take it as the root of that number, and then all to the power of the numerator of that fraction. And this one is the one with negative fraction. Just 1 over. The difference between this one and this one is just this one is negative fraction, then it is 1 over. Or it's just the same process for the denominator. Just take the root of the denominator of the fraction, and then all raised to the power of the numerator. And then of course you know that any number raised to the power 0 is 1. Even if it's 1,000, even if it's 1 million, even if it's 1,000 to the power 0, it's still 1. Any number at all, any number raised to the power 0 is just 1. And then this one, when two numbers are multiplying each other and the power is outside, just like the powers, those numbers has the power, but each of them has the power. So and then this one. So let's look at examples. Now, examples. Which is 10 to the power x multiplied by 10 to the power 4. 10 to the power 5 multiplied by 10 to the power 4. And from the laws of indices, which is the first one, that product of numbers with the same base. This is just the same thing as 10 to the power 5 plus 4. That is equal to 10 to the power what? 9. This is it. So you can just multiply and get to the final answer. Then the second one says B, which is 5y multiplied by 4y4. 5y multiplied by 4y to the power 4. Now, this is the same thing as 5, 4. Okay, let's forget about the bracket first. This is 5 times 4 times y times while 4. And this is still the same thing as 5 times 4 is 20. 20, then y to the power 1 plus 4. These two, this is to the power 1, this is to the power 4. Then when they have the same base, then when you add them, this is the same thing as 20y to the power 5. Now, another one there says, which is C, says 24x6 over 8x4. Now, this is the same thing as 24 over 8, then multiply by x6 over x4. And this is the same thing as 8 in 24 is 3. And then from the law of indices, the second one, that is division of numbers with the same base. This one is the same thing as writing x raised to the power 6 minus 4. Then from there, which is equal to 3x raised to the power 2. Right? Now, another one, I think that one is simple. Do we need to touch it? This one is just b to the power 2. When we talk about number with double powers, just 2 times 4. But let's just touch it. That number d. It says is b to the power 2 or to the power 4. And this is the same thing as b to the power 2 times 4. And this is equal to b to the power 2 times 4 is 8. And then the last one there, E. It says minus bracket minus 2b square bracket close all to the power 3. Now, look closely. This is the same thing as, of course, you know from here, this power raised to the power 2 is only for b, while the power 3 is for both 2 and b. So this is the same thing as minus 2 to the power 3 multiplied by b to the power to the power 2 all together. This is the power is outside, so it affects this one. So this is something as minus 2 to the power 3 multiplied by b to the power 2 all to the power 3. And this is the same thing as minus 8. Now, of course, minus 2 times minus 2 is 4, but then times minus 2 is minus 8. Minus 8 b to the power 2 times 3, like double powers. 2 times 3 is 6. So it's minus 8 to the times b to the power 6. Is that, I think that is all from there. Okay, now we still have another one to, if you notice all these ones, they are just under product and division. Okay, it touches double powers. So but I hope you got all these ones because they are very simple. These ones, they are very simple. We've not even gotten to the ones that are a bit hard. But these ones are simple. Just follow that rules and you get them. Now I think we have another one. Let me put it, okay, if I put it, it will not enter. And the first one that says minus d square all 3 divided by d4 times minus d. Now this is the same thing as minus d 2 times 3 raised to the power 6. Sorry, this is okay, raised to the power 6 all over this is d4 times minus d, and this is the same thing as minus in bracket because I'm multiplying the two minus d4 times d1. This and this they are the same, so which is equal to minus d6 all over minus d, and when we do d4 plus 1, which is the same thing as minus d6 all over minus d5 here. And this is finally, when these two go, this one cancels this one, we are left with d6 all over d5. And when we use the rule of division from that laws of indices, we will have d raised to the power 6 minus 5. And the final answer will now be d, which is, you can write d raised to the power 1 or d, that's just the same thing. So d. Let's go through it again. We are given minus d to the power 2 all in 3 over d to the power 4 multiplied by minus d in bracket, and there's no no power there, or do we have power there? No power. All over, okay, what am I even saying? Now this is it, this is the number, that same number. Now from the laws of indices, double power, you just multiply the two powers, and we got this one, minus d to the power 6 all over, this is d4, this is d4 multiplied by minus d1. And if you're multiplying these two numbers, it's just the same thing as bringing out the sign, that negative sign outside, and then this other one in bracket, which is d to the power 4 multiplied by d to the power 1. And then when you come here, this is the same thing, you brought this one down, and this is from the laws of indices multiplication, d to the power 4 plus 1. This is minus d to the power 6 over minus d to the power 5. And this is when subtraction cancels subtraction, we have this. And then from the laws of indices, when you have this, it's just the subtraction of the powers. So we have d to the power 6 minus 5, and what we have left is d. So that very last one, bracket 2 to the power 2x all 3 multiplied by 3 to the power 3x all 2, then all over 6 to the power 6x. Now look at this one. Like, what do I mean? This is it. Bracket 2 raised to the power 2x all raised to the power 3 multiplied by 3 raised to the power 2x all raised to the power 3 all over 6 raised to the power 6x. So what was there is 3x to the power 2, and now we changed it to 2x to the power 3. And of course, when you multiply this thing and multiply this thing, they will still give you the same answer. 3x times 2 is 6x, and then 2x times 3 will give you the 6x. And now from here we simplify further. This is equal to bracket 2 raised to the power 2x times 3 raised to the power 2x all raised to the power 3. Right? See, each of them is raised to the power. There is one rule we talked about, that if two numbers are raised to the power the same base, are raised to the power the same number, it is still the same thing as each of them raised to the power that same number. That is what we did here. These numbers are raised to the power, each are raised to the power 3. This one raised to the power, this one raised to the power 3. And then we brought it here, brought the 2 inside, and then all raised to the power 3. They are the same thing. This is over 6, whole number 6. Sorry, 6x. Now from here, we have something is common there. We have bracket 2 times 3 all raised to the power 2x, and then raised to the power 3 and over 6 raised to the power 6x. The same method we used for this one is the same thing we used for this one. Each of them raised to the power 2x is the same thing as both of them all raised to the power that's 2x. That is what we used here. And now from here we notice that we've got 2 times 3 is what? 6 raised to the power 2x. Sorry, this is 6 raised to the power 2x all raised to the power 3 over 6 raised to the power 6x. Right? And that from there, that is the same thing as 6 raised to the power 2x times 3 is 6x all over 6 raised to the power 6x. And now from there we've got something that is common. What is on the numerator is the same thing for the denominator. So we have this one cancels this one, so we have the answer as 1. Just like saying 2 over 2. When you cancel this 1, 10 over 10. When 10 divides 10, we will get 1. So that is the same thing here. So that's it for